Hello, we are going to start chapter 12, which is vectors and three-dimensional space. And why we want to learn this, because in calculus 4 we are going to learn multiple variable functions, like for example it's going to be z equals f, x, and y. So multiple variable function. Actually, this is in 3D, three-dimensional. So it's like we have x, y, z. So given x, y, we have a z value. So it's given like here we have x, y, and the point is given by x, y, z. Actually, this is similar to 2D. 2D is y equals fx. So this is in 2D. The point is given by x, y. So in order to learn multiple variable function, and we need to know what is the function in three-dimensional space and what's the three-dimensional space look like. Okay, and how the equations are given. So now let's see 12.1, three-dimensional coordinate system. Okay. Now let's take a look. Firstly, let's draw a 2D that a point is given by x and y. Okay, we call that two-dimensional space. Plane, actually, this is called plane. 2D plane. And what is three-dimensional space look like? Three-dimensional space look like this. Here we have x, y, z. Okay, and we have three axes, and they are called coordinate axes. And we have the right-hand rule. That means right-hand rule means if you use your hand, right hand, so if you start from x and go to y-axis, so your thumb point to z-axis. And actually, you can also draw the other way. So for example, if you choose this x, this is y, and this is z. Okay, so right hand rule. You can try use your right hand. So your thumb will point to z direction if you use the right hand rule. But this often, usually we just use this order. Now let's take a look. So we have this plane. Okay, it's called xy plane. And the plane made by z-axis and y-axis is called yz plane. It's kind of like yz plane here. And then we also have xz plane. Xz plane, if we look at this plane, that means when y equals 0. So all the points come to xz plane. Okay, and we also have the origin. Origin is given by 0, 0, 0, like this. And in 2D, the origin is just 2 zeros, right? Okay. Now let's take a look at the example. We are going to interpret the equations and inequalities geometrically in 3D. So given equation or inequality, so what does it look like? So interpret these equations and inequalities geometrically. The first one, let's take a look. Z greater and equal to 0. Let's take a look. So firstly, we want to draw a three-dimensional space. Okay, so we do x, y, z axis. So in the whole space, z can be anything, but right now it means z greater equals 0, so we can only choose the space which with z greater than 0. So it's all the points should be above x, y plane. Okay, so that means what? So if you see, that means half space So we separate the whole space into half. Only the top half. Half space above xy plane. Okay. Because we need the z greater than 0. Also include xy plane because it can also equals 0. The second one, x equals -3. In 2D, this is a line, right? We look this as a line. But you know, if in 3D, what does this mean? X, Y, Z. Same thing, we draw the 3D because we want to see geometrically what's the equation look like. What's the meaning of that? So x equals 3, so we choose x equals 3, -3. So -3, x is negative, so should be on the other side of x-axis, right? So -3 here. So all the x equals 3, so should be, you know, the plane satisfy all the x equals 3. So it should be something like this. Y and the z can be anything, but the x has to be -3. So it's kind of like we fixed, you know, x at -3. So the whole plane. So we can say this is the plane parallel to YZ plane and at x equals -3. Where's the plane? X equals -3. Okay. Third, z equals 0, x less equal to 0, and y greater than equal to 0. So z equals 0, what that means? All the z equals 0, that means it's on the xy plane, right? Should be on xy plane. But right now, is x should be less than 0, so should be on the other side, and y greater than 0, so actually it's on xy plane, that should be this part. Okay, on xy plane. And if I ask you what is this region, can you think? What's the region of this one? So this one should be, you know, here should be also z equals 0, but x greater equals 0 and y and greater equals 0. Alright, so now let's take a look at the last example. 4. Y greater than -1 less equal to 1. If we draw the three-dimensional space, x, y, z. Okay, so y from 91 to 1. Here's 91 and here's 1. And we know it's similar, you know, in 3D, what's the meaning of y equals 1? In 3D, that is a plane parallel to xz plane, so should be a plane like this. Okay, and right now the x y equals -1 should be here. And what our inequality? Y greater equal to 1, so should be all the region between those two planes, right? Because y greater equal to -1 and less equal to -1, something like that. Yeah, I can draw a better one, so let's see. This is kind of messy. Let's just draw this way. Y equals 91, y is 1, and we draw two planes here. And then the space in between. Okay. We say that is the slab between plane y equals 1 and y equals -1. And here, if I give you exercise, you can think about what is this one. Okay, and you can try this by yourself. So usually we look at z first. So x, y, z equals 0 means it's on xy plane. On xy plane, and x is greater than 0, so it should be the front part, and y less equal to 0. So that means y should be negative. So the region is this one. Okay. Now let's take a look at example 2. What points x, y, z satisfy the equation? Okay, so the equation looks like this. X squared plus y squared equals 4 and z equals. Firstly, let's take a look at the x squared plus y squared equals 4. What's the meaning of that one? But because we want to see what's this look like, we want to draw the three-dimensional space x, y, z. Okay. So right now we are going to do everything just in 3D, not 2D. Now x squared plus y squared actually equals 4. We know that's a circle. This is a circle in xy plane, right? Circle in xy plane. So we want to draw a circle, and the circle has radius too. And because in 3D usually we don't draw a circle like a real circle, we draw like this way, ellipse. Okay, something like this. And actually, if we just look at the first equation, that means z can be anything. Okay, if z can be anything, it's going to be like if we move the circle to the top and to the bottom, to the the lower part, and they become a cylinder. Actually, cylinder give us a cylinder. If we just have the equation like this in 3D, this equation in 3D means what? Means cylinder. Okay, but right now we have another equation says z equals 3. So we find where is z equals 3, and actually we fix our old z here at z equals 3, right? So what's the points satisfy the equation? Actually, if I draw, just means x y squared plus y squared satisfy the circle, and all the z equals 3. So it's circle at z equals 3 should be that one. And right now I can ask you another question. You can think about this. If I give you inequality x squared plus y squared less and equal to 4 and z equals 3, do you know where are the points? Okay. Let's see. In that case, we have the same thing, x squared y squared plus less equal to 4 give us a cylinder. Okay, but z equals 3. So right now z equals 3 because this less equal to, so include all the points inside the circle. So it's going to be a disk. So this one is just circle at z equals 3, and this is a disk at z equals 3, right? So you can see the difference. And let's take a look at the exercise problem. You can try this. X squared plus y squared equals 4, z equals -2. Okay, you can draw this. Where are the points? X squared plus y squared equals 4, same thing. It's going to be a circle in 3D, and then we draw a cylinder, and then we make z equals -2. Z equals -2 should be the lower part of xy plane, and then we draw the circle. So actually This is the circle. Satisfy just two equations. Okay, now we are going to do the distance in 3D. So in 2D, let's have a quick review. In 2D, if we have 2 points, P1, P2, so P1 is given by x1, y1, x2, y2. Do you still remember what's the distance between those two? So the distance is given by the formula here. x2 minus x1 squared plus y2 minus y1 squared, right? So this is in 2D, the formula for the distance. So in 3D, we have similar thing. So here we say formula 1, distance between 2 points. And right now the 2 points should be x, y, z coordinate, right? x1, y1, z1. And P2 is x2, y2, z2. Okay, is given by this one. Is, so we use d as distance. Or sometimes we just write down P1, P2, and kind of like x value, that means the length. So which equals square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So similar to the distance in 2D, we just have one more term here. Okay. Now let's take a look at example 3. Find the distance between two given points. Between 2, 1, 5 and P2, which is -2, 3, and 0. So let's see, we can write down the distance as square root of x2 minus x1, so square, right? And plus 3 minus 1 square and plus 0 minus 5 square. So this equals what? This equals 4 square plus 2 square plus 5 square. And after we simplify, so this is 16 plus 4 plus 25. So should be root of 45. And if we simplify this one, you don't have to, but I like to give a easy, like a simplified answer. 45 is 9 times 5. So take the 9 out, becomes 3, 3 root of 5. That's the answer. Okay, and try this one. So distance equals So the answer should be this one, right? Okay, it's pretty easy, just a formula thing. Now I'm going to give you another formula. So this is a formula for the sphere. Okay, sphere is in 3D. Formula 2. It's called the standard equation for sphere of radius A and center at x0, y0, z0. Okay. Yes, this one. Standard equation for sphere. So it's like similar to 2D. 2D we have circle, right? Circle should be x. Okay, general form should be x minus x naught squared plus y minus y naught squared equals r squared. and x0, y0 is the center, and the radius is r. That's a circle. This is in 2D. And in 3D, that becomes sphere. So if we draw the graph, it's kind of like, okay, draw circle, and because 3D, it looks like this. Okay, and this actually center at origin, right? But general form center at that one should be x minus x0 squared, y minus y0 squared plus z minus z0 squared and equals a squared, because here a is the radius. So this is formula 2. Now let's take a look at this sphere. So if I give you this thing, can you see where is the center and what is the radius? Okay, so center equals what? And the radius equals what? Radius equals 3, because 9 is the 3 square, right? And the center should be -1, 2, and 4. Z minus Z0, x minus -1, right? And now let's take a look at this example. We are going to find the center and the radius of a sphere if the sphere is not given by the standard form. Find the center and radius of the sphere. And the sphere is given by this form: x squared plus y squared, 4x minus 6y plus 2z plus 6 equals 0. Now let's take a look at this one. This is not standard, so we don't know what center and radius from here, right? So we have to do complete square method. Okay, complete square method means what? So we're going to combine all the x term together, all the y term together, and write all the z term together, and we can move the constant to the right side. Okay, that's what we're going to do. So let's see. X squared plus 4x, and here I leave a little bit space here, and y squared minus 6y, I leave another space here, and plus z squared plus 2z, a space here, and when we move 6 to the right side, it's -6. Now complete the square, that means we add some number to make those terms into square thing. So we know here we should add a 4, right, based on the middle term. Based on the 6y, we know here we should add 9, here we should add 1. And because in order to make the equation same, we added those numbers on the left side, we also need to add those numbers on the right side. 4 plus 9 plus 1. So we still have the same equation. Right now, complete the square. This is called the complete square method. Okay, so it becomes x plus 2 squared, y minus 3 squared, z plus 1 squared, and the right side just simplify. So here should be 10 plus 4, 14, minus 6 should be 8, right? Okay, so let's see what is center. 92, 3, 91, and the radius root of 8, so which is 2 root 2. Okay, so this is how we find the center and the radius for a general sphere equation. So you can try this. It's better for you to do this by yourself, but here I'll give you the solution. Okay, so let's change this into 6. center is -3, 0, and 2, and the radius is root of 12, which is 2 root 3. Okay, so in this section, it's just introduction of three-dimensional space. Right now, when we need to know for given equation and inequality, how to tell what they are, okay, what they represent. So where are the points? And then we need to know how to find the distance between 2 points in 3D, and also what is the center and the radius for a general given sphere equation. Okay, so we can stop here today.